National Mathematics Day, December 22nd, the birthday of Srinivasa Ramanujan. The man who knew infinity. An equation means nothing to me unless it expresses a thought of God, is the words by Srinivasa Iyengar Ramanujan. This is his signature and this is the magic square by him. Early life, his childhood. He was born on 22nd December 1887 at Kumbakonam, Madras Presidency, British India. He was died on 26th April 1920, Cherput, Madras, British India. This is his street and this is his house. Parents. His father was Kuppaswamy Srinivasa Iyengar, a clerical assistant to a cloth merchant. His mother was Komalatammal, who was a housewife. His marriage. He was married with a 9-year-old girl, Janaki Ammal, when he was 12, but did not live with his wife till she reached the age of 12. This is his father and mother. This is a family picture of them. He is along with his wife Janaki Ammal. Emergence as mathematician. He was a self-taught mathematician, no formal training in mathematics. Even before just turning to 10, he passed his primary education with excellent score in English, Tamil, geography, mathematics and arithmetics. Ramanujan taught at the age of 7. Once, his teacher said when the zero is divided by any number, the result is 0. Ramanujan thought immediately, asked his teacher whether 0 divided by 0 gives 0. This shows early sign of his genius. He also shown how to solve cubic equations in 1902. He developed his own method to solve the quadratic. He was an expert in trigonometry at the age of 12. Discovered theorems of his own. His education was in Government Arts College, Panchayats College and Trinity College, Cambridge. He left the college without a degree and pursued research in mathematics. Picture of him in the college. A step ahead. He met V. Ramaswamy Iyer, who was the founder of Indian Mathematical Society. When Ramanujan showed him his book, Iyer later recalled, "I was struck by an extraordinary mathematical result contained in the notebook. I had no mind to smother his genius by an appointment in the lower ranks of the revenue department." He introduced him to the Ramachandra Rao, R. Ramachandra Rao, who was the secretary of Indian Mathematical Society. This is a picture of R. Ramachandra Rao. He doubted him, but later understood his integrity. Rao agreed to give him another chance and listened as Ramanujan's discussions on elliptic integrals, hypergeometric series, and his theory of divergent series, which Rao said ultimately convinced him of Ramanujan's brilliance. With Iyer's help, Ramanujan had his work published in Journal of Indian Mathematical Society. The first problem which he proposed was this. He formulated an equation to solve the infinity nested radical problems. One of the problems solved by Ramanujan is this one. Introduction with G. H. Hardy. G. H. Hardy was an English mathematician known for his achievements in number theory and mathematical analysis. Hardy recognized some of Ramanujan's formulae, but others seemed scarcely possible to believe. This was that formulae. Hardy was also impressed by some of the Ramanujan's other work related to infinite series. That was this. Ramanujan Hardy number 1729. Hardy arrived in a cab numbered 1729 and he commented that the number was uninteresting. Ramanujan claimed that it was the smallest natural number which can be written as sum of cubes in two ways, that is 1 cube plus 12 cube, which is also equal to 9 cube plus 13 cube. It is also the product of three prime numbers, 7 into 13 into 19. This was the cap which he Ramanujan is known for. Ramanujan is known for Lentov Ramanujan constant, mock theta functions, Ramanujan conjecture, Ramanujan prime, Ramanujan Solder constant, Ramanujan theta function, Ramanujan's sum, Rhodker-Ramanujan identities, Ramanujan's master theorem, Ramanujan's Stato series. Magic square. This is the magic square which was proposed by Srinivasa Ramanujan. When we add all the numbers in a row, we get the sum as 139, similarly of that of the columns, diagonals, corners, and all these boxes which are of the same colors. The sum will be 139. Then, in his magic square, the first row is 22, 12, 18, 87. What is this? Do you remember this? Yes, this is his birth date. Contributions. Ramanujan made substantial contributions to the analytical theory of numbers and worked on elliptic function, continued fractions, and infinite. In 1900, he began to work on mathematics summing geometric and arithmetic series. He worked on divergent series. He sent 120 theorems on simple divisibility properties of the partition functions. Partition of whole numbers is another similar problems that captured Ramanujan's attention. Subsequently, Ramanujan developed a formula for the partition of any number which can be made to yield the required result by a series of successive approximation. And this is an example for partition, where 4 can be written as 4, 1 plus 3, 2 plus 2, 1 plus 1 plus 2, 1 plus 1 plus 1 plus 1. And he also said that the highest composite number listed is 6746328388800, which is having 10,080 factors. Moving to the other contributions. Fermat theorem. He also did considerable work on the unresolved Fermat theorem, which states that a prime number is of the form 4m plus 1 is the sum of two squares. Euler's constant. By 1904, Ramanujan has begun to undertake a deep research. He investigated the series 1 by n and calculated the Euler's constant up to 15 decimal places. Ramanujan's home state, Tamil Nadu, celebrate 22nd December as State IT Day, memorizing both the man and its achievement as a native of Tamil Nadu. Mock theta function is being described here. Ramanujan's honor. He has been awarded BA degree by research, later PhD in March 1916. He became the first Indian to be elected a Fellow of Trinity College, Cambridge. He became a Fellow of the Royal Society in 1980. On 6/12/1917, he was elected to London Mathematical Society. A stamp was released by the government in 1962 in honoring Ramanujan. And this is a picture of his post. Thank you.